Welcome to this crucial module on managing, monitoring, and securing AI systems, with a specific focus on monitoring data ingestion quality, search index health, and relevance performance. Let us jump right in. Welcome to this crucial module on managing, monitoring, and securing AI systems, with a specific focus on monitoring data ingestion quality, search index health, and relevance performance. When we build generative AI solutions, especially those using Retrieval-Augmented Generation, or RAG, the intelligence of our AI agent is entirely dependent on the quality of the data it can access. Prompt engineering helps guide how a model responds, but it cannot give the model knowledge it doesn't already have. Language models are trained on massive datasets, but that training data inherently has a strict cutoff date and completely lacks your organization's private information. When a model lacks relevant context, it might generate responses that sound incredibly plausible, but are factually incorrect. Microsoft Foundry IQ provides a highly advanced shared knowledge platform that seamlessly connects your AI agents to real-time enterprise information. But how does that data get there? It relies on the robust capabilities of Azure AI Search. Azure AI Search acts as the core engine for knowledge mining, extracting insights from your unstructured documents. If your data ingestion pipeline is broken, or if your search index is unhealthy, your agent will blindly rely on its base training data, inevitably leading to dangerous hallucinations. In this comprehensive session, we will deep dive into the entire data lifecycle. We will explore how to monitor the automated indexers that ingest data from your storage repositories, how to ensure your AI skillset enrichments are processing correctly, and how to continuously validate the health of your populated search indexes. Furthermore, we will critically examine relevance performance. We must actively measure how well our system retrieves the right documents to answer user queries by focusing on core characteristics like grounding, citation, relevance, and completeness. By establishing rigorous monitoring across these three domains: ingestion, index health, and relevance, you ensure your AI agents consistently deliver accurate, verifiable, and highly valuable enterprise insights. Let us jump right into the architecture of data ingestion. This script utilizes the Azure SDK to connect directly to the search index. Establishing this programmatic connection is the first step in validating index health and querying the ingestion status. This high-level flowchart illustrates the data lifecycle. The very first phase of maintaining a robust knowledge mining solution is ensuring the exceptional quality of your automated data ingestion pipeline. At the absolute heart of Azure AI Search solutions is the creation of an index, which physically contains your highly optimized, searchable enterprise content. This critical index is created and systematically updated by a highly automated component known as an indexer. The indexing process always starts directly at your data source. This could be an Azure Blob storage container filled with thousands of complex PDF manuals, a structured relational database, or a secure Microsoft SharePoint repository configured seamlessly through Foundry IQ. When the indexer runs, it performs a complex operation called document cracking. It securely opens the raw files, reads the dense text, and systematically extracts essential metadata. Monitoring this precise ingestion phase is absolutely critical for your architecture. If an indexer encounters corrupted files, highly unsupported document formats, or severe network connectivity issues with the underlying storage layer, it will silently fail to ingest that specific data. If you are not actively monitoring your indexer's run history and detailed error logs, your search index will slowly become outdated and dangerously incomplete. You must systematically track the ingestion quality by consistently monitoring the success rates of these scheduled indexer runs. Are all enterprise documents being successfully cracked? Are there specific proprietary file types that are consistently causing pipeline bottlenecks? By proactively monitoring the overall data ingestion quality, you guarantee that your AI agents are always reasoning over the absolute most comprehensive, up-to-date, and mathematically accurate representation of your organization's private data. Without a flawless ingestion pipeline, everything downstream will inherently suffer from massive missing context. This conceptual code snippet retrieves the operational status of a named indexer. By evaluating the last_result.status, you can programmatically detect and alert on critical data ingestion failures in real time. This diagram maps the indexer execution process. Data sources feed the indexer, which performs document cracking. Successes move to enrichment, while failures are actively logged to your monitoring systems. Once the raw data is successfully ingested and cracked, it often requires significant transformation before it is genuinely useful for an AI agent. This brings us to monitoring search index health and the execution of AI enrichments. Extracting raw text is rarely sufficient for complex business needs. The sophisticated enrichment pipeline orchestrated by an Azure AI Search indexer utilizes a skill set to create highly valuable AI-enriched fields. The indexer applies each specific AI skill in a strict sequence, heavily refining the index document at each step. These powerful built-in skills seamlessly include functionality from Microsoft Foundry tools, such as Azure Vision for optical character recognition and Azure Language for advanced language detection, named entity recognition, and aggressive personally identifiable information extraction. You must actively and continuously monitor the overall health of this complex enrichment pipeline. If your OCR skill suddenly fails to process a massive batch of image-heavy scanned invoices, that critical financial text will simply never reach the final searchable index. Monitoring search index health involves systematically verifying that these complex AI skills are executing successfully across all documents, and that the resulting enriched fields are being accurately mapped into the final index schema. You can also persist this extracted, highly enriched information into a structured knowledge store for deeper secondary data analysis. A truly healthy search index is one where the data is not just present, but thoroughly enriched, accurately structured, and completely free of any processing pipeline errors. This pristine index health is the absolute non-negotiable foundation that allows your generative AI agents to flawlessly execute advanced multimodal reasoning over your entire enterprise knowledge base, ensuring high-quality output. This JSON fragment represents a built-in OCR skill definition. Monitoring the health of your index requires ensuring these skill set transformations execute without error, correctly populating the extracted_image_text target field. This visual demonstrates the skill set pipeline. Cracked documents pass through AI skills like PII redaction and OCR. Execution health is constantly verified before persisting the enriched data into the final search index. With a perfectly healthy, fully populated search index in place, we must radically shift our focus to evaluating the actual relevance performance of the retrieval system. When an AI agent autonomously queries the knowledge base via Foundry IQ, we must ensure the retrieved documents actively produce high-quality, perfectly accurate answers. Evaluating good retrieval-augmented generation responses requires monitoring 4 absolutely critical characteristics. First is grounding. You must mathematically verify that the information in the final response comes strictly from the knowledge base, completely preventing the generative model from hallucinating dangerous facts derived from its base training data. Second is citation. Every single factual claim the agent makes must include explicit, highly verifiable source references pointing directly back to the ingested documents. Third is relevance. The monitoring system must objectively measure whether the retrieved content actually answers the user's specific question, rather than just returning vaguely related keyword matches. Finally, completeness. You must actively ensure all necessary information is thoroughly provided to the user, not just isolated, unhelpful fragments. To properly monitor these metrics, you must set up rigorous automated test conversations. You should proactively create a comprehensive evaluation dataset containing straightforward factual questions, complex questions requiring multi-document synthesis, and intentionally ambiguous questions. If your monitoring reveals that responses frequently fail these 4 critical criteria, perhaps the agent is randomly missing citations or aggressively hallucinating out-of-scope answers, you have identified a severe relevance performance issue. Identifying these relevance failures early is essential for maintaining deep user trust and strict enterprise compliance before the AI agent is deployed to production. This Python code runs an automated evaluation script. By enforcing a strict assertion on the groundedness metric, your pipeline immediately flags critical relevance performance failures, preventing bad data delivery. This flow charts the evaluation of RAG metrics. Agent queries pass through Foundry IQ, and the responses are strictly evaluated for grounding, citations, and completeness before delivery to the user. When your continuous monitoring detects a severe drop in relevance performance, you must actively intervene to aggressively optimize the retrieval mechanisms within Azure AI Search and Foundry IQ. You can dramatically improve retrieval quality through 3 highly advanced architectural optimization techniques. The first crucial technique involves meticulously configuring scoring profiles. Scoring profiles allow you to algorithmically boost specific fields or unique document attributes, aggressively surfacing the most statistically relevant results directly to the top of the search stack. For example, you might powerfully boost documents that have a more recent publication date, or explicitly match a high-priority document title field. The second, and arguably most revolutionary technique, is enabling semantic ranking. Unlike traditional basic keyword matching, semantic ranking uses advanced AI models to deeply understand the true contextual meaning and subtle intent behind a user's prompt, vastly improving the semantic relevance of the retrieved text chunks. The third vital optimization technique is implementing custom analyzers. If your enterprise data contains highly specialized content, such as complex internal product codes, dense HTML tags, or proprietary medical terminology, standard text analyzers will absolutely fail to index them correctly. Custom analyzers allow you to explicitly define how these unique terms are accurately tokenized and searched. By deeply analyzing your system's relevance performance telemetry, you can precisely tune your scoring profiles, toggle semantic ranking, and deploy custom analyzers to definitively resolve any identified retrieval bottlenecks. This continuous cycle of rigorously measuring relevance and aggressively applying these powerful optimization features completely guarantees that your generative AI agents always receive the most accurate data. This query explicitly enables the semantic query type, shifting from basic keyword matching to advanced AI-driven intent understanding, thereby massively optimizing relevance performance for complex queries. This diagram shows the path to recovery when low relevance is detected. The system architect applies scoring profiles, semantic ranking, and custom analyzers to create a highly optimized index yielding improved accuracy. Moving from isolated testing to a live, scalable production environment introduces entirely new monitoring challenges for your AI architecture. Once your integrated generative AI agent is deployed to users, you must closely and obsessively monitor actual real-world usage patterns. Real-world users will inevitably ask complex questions entirely differently than your carefully scripted internal test scenarios anticipated. Some questions will undoubtedly hit obscure, unhandled edge cases you never initially prepared for. Others will clearly reveal critical missing gaps in your knowledge base content, where the automated data ingestion pipeline simply lacks the required source manuals. As you actively monitor these live interactions and continuously evaluate the resulting relevance performance, you must iteratively adjust your system configuration to maintain strict quality. If you notice the deployed agent struggling with specific retrieval scenarios, you must decisively refine your explicit agent instructions. Highly effective agent instructions strictly specify when the agent must retrieve information, how to meticulously format required citations, and what exact phrasing to use as a safe, graceful fallback when the requested answer is simply not found in the search index, such as stating "I do not have that exact information." This continuous, rigorous feedback loop monitoring data ingestion quality, validating search index health, measuring complex relevance metrics, and constantly refining instructions, is the ultimate hallmark of a mature, secure, enterprise-grade AI deployment. Thank you for joining this comprehensive architectural session. If you found this technical deep dive valuable, please actively like and subscribe to our channel. For premium certification prep, including massive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides, be sure to visit quicktechie.com. Keep optimizing, and I will see you next time. These refined system instructions implement a strict, graceful fallback. Based on production monitoring, you forcefully instruct the agent to avoid guessing, actively mitigating relevance failures when data ingestion is missing specific facts. The continuous iteration loop in production, live telemetry, is monitored to identify missing knowledge in edge cases. These insights directly drive fixes to data ingestion and agent instructions, looping back to a stronger production deployment.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.